Have you ever asked yourself how our amazing planet Earth was created? It's a question that has so much intrigue and wonder. In this video, we'll explore the intriguing process of how Earth was created and why it's such an intriguing enigma. Learning how our world came to be is not only illuminating Earth's history, but also provides us with a glimpse of life's beginnings and the very foundations of all that exist around us. So, let's take this trip back in time and find out about the grand narrative of how our world came into existence. An estimated 13.8 billion years ago, the world started in an event called the Big Bang. This was not an explosion, but an extremely fast inflation of space itself, where everything we see today began as a single infinitely dense point. As the universe inflated, it cooled, and it was possible for matter to condense, eventually making its way to stars, galaxies, and other things in the universe. Stars, such as those that we see at night, were important in forming the planets. They combine elements such as hydrogen and helium in their centers, and when these stars die, they go out with a bang in a huge supernova explosion. These supernovae spew heavy elements such as carbon, oxygen, and iron out into space, where they then group together to create new stars, planets, and eventually the planet we inhabit today. It's this amazing process that established the basis of the planet we know today. Around 4.6 billion years ago, our solar system formed from a giant cloud of gas and dust. The cloud was a solar nebula that consisted of debris from previous stars and supernovae. Gradually, gravity started to bring the particles within the cloud closer to each other, and they began to crash and adhere, a process called accretion. As more matter accumulated, it formed larger and larger clumps of matter, ultimately shaping the sun at the center of the cloud. The other gas and dust clumped together as well, creating the planets, moons, and other objects of the solar system. Gravity played the most important role in doing this, bringing all the dispersed material into tight clumps that would ultimately become the planets, such as Earth. This slow buildup of material laid the foundation for Earth's creation and its position in the solar system. Early in Earth's creation, the planet was a seething, molten, and turbulent world. This heat was due to perpetual impacts with asteroids, comets, and other space debris. When these objects hit the accreting Earth, they dumped tremendous amounts of energy into the planet's surface. As this continued, Earth's interior started to separate, with denser elements such as iron and nickel settling to create the core and lighter elements, creating the mantle and crust. All around, volcanism was widespread, giving off the gases that would one day create the early atmosphere. The planet's surface was repeatedly restructured through such violent collisions and eruptions, forming a topography utterly unlike the Earth we have today. It was a fiery world of extreme intensity and ferocity, yet it paved the way for the calmer surroundings that we now live in. One of the most intriguing incidents in the early history of Earth is the origin of the Moon. The most popular explanation is the giant impact hypothesis, which states that approximately 4.5 billion years ago, Earth was hit by a Mars-sized object, commonly known as Theia. This devastating collision was so powerful that it produced a humongous explosion, and a tremendous amount of debris was ejected into space. Eventually, this debris clumped and coalesced to create the Moon. The formation of the Moon had a significant effect on Earth in various ways. First, it stabilized Earth's axis, keeping the planet from wobbling excessively, which made the climate more stable. The Moon also significantly affects Earth's tides by its gravitational pull, which produces the rise and fall of the oceans. Without this enormous impact and the Moon that it created, Earth's environment would have been much different, unstable, and maybe less life-friendly. As the Earth continued to cool, the molten surface started solidifying and created a solid crust. Volcanic eruptions, though, were frequent and emitted gases such as carbon dioxide, water vapor, and nitrogen through volcanic outgassing. Over time, these gases accumulated to create the early atmosphere of Earth. With continued cooling, the water vapor contained in the atmosphere condensed and created the initial oceans. These oceans played a key role in establishing a stable climate for life to ultimately flourish. The water acted as a protective medium that stabilized the temperature of the planet and shielded early life forms from dangerous radiation. Of greater significance, the oceans were also the cradle of the initial life on Earth, providing the conditions under which chemical reactions could occur that are thought to have been important for the origin of life. Had these early,